So, hello everybody. Today we are going to see the reading from 3.3.6. Earlier, we had completed till before check your progress one, and today we will start from implementation. So, what do you mean by implementation? So, we see here that during implementation, you turn system specification into working system that is tested and put into use. Implementation includes coding and testing and installation. So it includes coding, testing, and installation. Then what is there? During coding, programmers write programs that make up the system. During testing, programmers and analysts test the individual programs and the entire system in order to find and correct errors. During installation, the new system becomes a part of the daily activities of the organization. Application is installed or loaded on existing or new hardware, and users are introduced to new system and trained. The analysts begin planning for testing and installation as early as the project initiation and planning phase. Since testing and installation require extensive analysis in order to develop the right approach, installation of the system can be done in the following three ways. Direct conversion. In this type of conversion, the software is directly installed at user's site. Parallel conversion. In this type of conversion, both the old and new systems are run in parallel for some time. After monitoring the new system for a reasonable period of time, and if it is performing well, then the new system is implemented, replacing the old one. Now comes the phased conversion. In this type of conversion, the system is installed module by module. Implementation activities also include initial user support, such as the finalization of documentation, training programs, and ongoing user assistance. Note that documentation and training programs are finalized during implementation. Documentation is produced throughout the life cycle. Implementation can continue for as long as the system exists, since ongoing user support is also part of implementation. Despite the best efforts of analysts, managers, and programmers, however, installation is not always a simple process. Many well designed systems can fail if implementation is not well managed. The management of implementation is usually done by the project team. Maintenance. The final phase is maintenance. When a system is operating in an organization, users sometimes find problems with how it works and often think of better ways to perform its functions. Also, the organization's requirements with respect to the system change with time. During maintenance, programmers make the changes that users ask for and modify the system to reflect and support changing business conditions. These changes are necessary to keep the system running and useful. Maintenance is not separate phase but a repetition of the other life cycle phases required to study and implement the needed changes. Thus maintenance is an overlay to the life cycle rather than a separate phase. The amount of time and effort devoted to maintenance depends a great deal on the performance of the previous phase of life cycle. There comes a time, however, when an information system is no longer performing as desired. When maintenance cost becomes prohibitive or when the organization's needs has changed substantially, such problems are an indication that it is the time to begin designing the system's replacement. Therefore, completing the loop and starting the life cycle over again. Often, the distinction between the major maintenance and new development is not clear, which is another reason why maintenance often resembles the life cycle itself. Maintenance is of three types. Corrective maintenance. In this type, the errors that creep into the system are removed. Hence, the name corrective maintenance. Adaptive maintenance. It is done to adapt with the changing external factors. For example, if the government rules changes regarding the dearness allowance from 52% to 58%, then the changes have to be made in the information system to adapt with the changing scenario. Perfective maintenance. This is done to satisfy the user's requirements to make the system more and more perfect. The SDLC is a highly linked set of phases where output of one phase serves as input to the subsequent phase. Throughout the system's development life cycle, the system's development project needs to be carefully planned and managed. Therefore, the larger the project, the greater is the need for project management. Products of SDLC phases: project identification and selection, priorities for systems and project, architecture for data, networks, hardware, and information system management are the results of the associated system. Project initiation and planning, detailed work plan for project, specification of systems scope and high level system requirements, assignment of team members and other resources, analysis, description of current system, need to enhance or replace current system, explanation of alternative systems, and justification of alternatives. Logical design, functional and detailed specification of all system elements, data, process, input and output. Physical design, technical detailed specifications of all system elements, that is programs, files, network, system software, etc., and acquisition plan for new technology. Implementation, code documentation, training programs, and support capabilities. Maintenance, new version of software with associated updates of documents, training, and support. Approaches to development. In the continuing effort to improve the systems analysis and design process, several approaches have been developed. Attempts to make system development less of an art and more of a science, usually referred to as engineering techniques, are applied to system development. We will discuss prototyping, followed by introduction to joint application design and participatory design. Prototyping, designing and building a scaled down but fundamental version of a desired system, is known as prototyping. A prototype can be built with any computer language or development tool to simplify the process. A prototype can be developed with some fourth generation languages, 4GLs, such as query, screen, and report design tools of a database management system DBMS, and with tools called computer aided software engineering CASE tools. Using prototyping as a development technique, the analyst works with user to determine the initial or basic requirements of the system. The analyst then builds a prototype. When the prototype is completed, the user works with it and tells the analyst what they like and do not like about it. The analyst uses this feedback to improve the prototype and take the new version back to the user. This process is iterated until the users are satisfied. Two key advantages of the prototyping technique are the large extent to which prototyping involves the user in analysis and design, and its ability to capture requirements in concrete rather than verbal or abstract form. In addition to being used stand-alone, prototyping can also be used to augment the SDLC. Prototyping is a form of rapid application development or RAD. The fundamental principle of any RAD methodology is to delay producing detailed system design document until the user requirements are clear. The prototype serves as the working description of needs. RAD methodologies emphasize gaining user acceptance of the human system interface and developing core capabilities as quickly as possible. Joint application design. In the late 1970s, systems development personnel at IBM developed a new process for collecting information system requirements and reviewing systems designs. The process is called Joint Application Design JAD. The basic idea behind JAD is to bring structure to the requirements determination phase of analysis and to reviews that occur as part of design. Users, managers, and system developers are brought together for a series of intensive structured meetings run by a JAD session leader who maintains the structure and sticks to the agenda. By gathering the people directly affected by an information system in one room at the same time to work together to agree on system requirements and design details, time and organizational resources are better put to use. An added advantage is that group members are more likely to develop a shared understanding of what the information system is supposed to. Participatory Design PD. Participatory Design PD represents a useful alternative approach to the SDLC PD, emphasizes the role of the user much more than other techniques do. In some cases, PD may involve the entire user community in the development process. Each user has an equal share in determining system requirements and in improving system design. In other cases, an elected group of users control the process. These users represent the larger community under PD. Systems analysts work for the users. The organization's management and outside consultants provide advice rather than control. PD is partly a result of the role of labor and management in the workplace where labor is more organized. and is more intimately involved with technological changes. So here comes the check your progress 2, and we will stop till here. In the next lecture we will complete the rest. How many pages are there? Yes, not much. 1 2 3 4 5 pages. Okay, we will see in the next lecture. Till then, bye bye.